Right, so thanks a million. I'll try and keep an eye on time. So, yeah, I'm Karen Doyle. I'm a professor in physiology in was the School of Medicine, now the School of Pharmacy and Medical Sciences. So I wasn't quite sure what to talk to you about today, really. So what I'm going to do is I'm going to tell you a little bit about what I do in terms of my research. And I'm also then going to talk to you just the kinds of ways that I try to advocate, right? So that you get a sense of, I'm not sure if I'm doing right, wrong, I don't know, but perhaps they can stimulate some discussion. So I study stroke, specifically the kinds of strokes that are actually caused by a blood clot that blocks a blood vessel. I won't spend too much time going into nitty-gritty, but since 2015, there's been two approaches really to treat somebody who's had an acute stroke, and it involves either the use, of a drug which can dissolve the clot, which was actually around since the late 1990s. But there's this new approach which is called thrombectomy, where they physically go in and remove the clot. Now, obviously, that's very advantageous to the patients that it helps. From my perspective, it means that I have this tissue that I can study. Now, I'm a neuroscientist, but I actually study blood clots now to try to understand the cause of the strokes, right? So essentially, that's what I'm interested in, and I get access to blood clot tissue. Not all clots are the same. You might think a blood clot is a blood clot. We've all, generated clots. We've all had bleeds, but they actually vary considerably, which I'll just very briefly show you. And this has actually huge impact on, how well you might actually physically be able to remove that clot. And if you can get rid of the clot, you can, restart blood flow, and the patient's brain health will be massively improved, right? So I work in the area of, obviously I'm a co-director in CORAM, and my work is very much embedded within CORAM. It's around developing new medical device technology that's going to help in this space. So, for example, understanding how the blood clot works, or characteristics of that clot, helps to inform thrombectomy medical device design, and ultimately with a view to improving patient outcomes, the plan. Now, this is a histopathology slide of a blood clot, right? So we do histology, we make essentially pretty pictures from this. These are components that you find within blood clots: red blood cells, white blood cells, fibrous material called fibrin, and platelets and others. There's all sorts of things in there. And essentially, I just wanted to show you this graph. This was a graph that we generated from one of our studies called the Restore Registry, where we analysed nearly 1,500 clots that were extracted from people who had suffered strokes. And essentially, to take from this slide is the yellow colour is reflecting the red blood cells on that previous stain that you saw. It literally goes from one extreme to the other, as you can see from the graph. So almost fully red blood cells down to virtually none whatsoever, right? So blood clots are different. They do vary, and it has a marked impact on how well the kind of technology that we have available, how well it might actually remove them, right? So that's the kind of thing that we study. What we do then is we correlate the clot components with, for example, clinical data, with a view to see if we can advise ultimately clinicians as to the kind of clot that they're dealing with and what might be the best approach to remove it. And anything that allows them to get that clot out and quickly has a huge impact, positive impact on patient outcome. So we're working on a number of different studies. For example, a rad clot study that has been funded by the University of Galway Global Challenges. It was an award from that scheme. We're actually trying to develop an algorithm that can kind of tell the features of that clot. That's the clot that caused the stroke there. So we're trying to actually see if we can find out nitty-gritty so that it can inform a procedural approach actually when somebody does have a stroke. We are also working with another company called Sensome, where we're developing technology, again, medical device, that can basically be sent up through the vasculature to come into contact with the clot, and again, through electrical impedance in this case, inform what the clot's like. Anything that you can tell the clinician so that it can advise them on the best approach has to be positive to the patient. So that's all I'll tell you about my work. But essentially, there is certainly potential for this research to influence medical device design. We would have some evidence that we can do that. Influences clinical practice, right? Maybe a little bit more aspirational, but some evidence that we can do that. Influence clinical guidelines and influence policy around stroke care. Well, they're kind of the holy grail. Now, it can, but I'm just a very small cog in a very big wheel, right? So I think there's potential for sure here, but how much I actually influence it, that's different. In terms of science advocacy, this is just my thoughts on how I go about it. As a scientist, there are certainly things that I can do, which I'll just briefly touch on. Also in a leadership capacity, because again, I am probably at that stage of my career where I have actually had experience on a few different committees and various things. So I'll just briefly tell you about that. But the one thing that I have always observed is collaboration is absolutely key. The more you are linking in with other people, this definitely helps. So in terms of, as a scientist, impactful research, well, that's the start. That's where we all start. That's where we all end, right, at the end of the day. Obviously, we try to publish in the best journals we can. Something that I think is really useful, personally, just from an impact perspective, is those kinds of articles that are collaborative, where you try to come up with a consensus around something in your area. And I have been lucky enough to be involved in a number of Delphi consensus statement type papers. These can be very impactful, I think, in being actually able to inform people outside of your actual area. In terms of raising awareness, engaged research just generally, obviously EPE, PPI, these are really important, and especially through CORAM I've had the opportunity to get involved in a whole array of things. So for example, we had a documentary around our work called A Tiny Spark through the Science on Screen programme, but also I've had the opportunity to link in with CREE, is a patient-focused charity, actually based in Galway, but they're a voice for stroke patients and people who've had serious heart problems as well. And they're wonderful partners in terms of the PPI type of story. So that's a really important aspect to my work. Also, there's the Irish Heart Foundation, would be the society, the national society in Ireland, where my work could have impact with a large group of patients. So, for example, there are stories about our work on the Irish Heart Foundation website. You know, it's that kind of thing. I think, well, I try, right? I try to do this kind of thing. In terms of networking, I think this is crucial. So through my work, because I obviously have to work with a lot of clinical teams in hospitals, mostly throughout Europe, but in actual fact, internationally, globally now these days. Many of them are genuinely key opinion leaders. The clinicians tend to have a very strong voice naturally in terms of anything to do with policy around healthcare. And my being able to actually talk to them, I think has a massive, that's probably one of the largest impacts that I can have, to be quite honest, rather than me, my voice, their voice, but me being able to inform them. I think that's very powerful. Also, industry interactions, which in CORAM were very well placed to obviously talk to. This is massive as well. And then another thing just that I'll briefly touch upon is involvement in scientific and professional societies. And in my area, it's the European Stroke Organisation is a very key one for me. The European Stroke Organisation, for example, have developed a stroke action plan in Europe from 2018 to 30. Now, ESO is very much, the vast majority of members within this organisation are actually clinical. So one thing that I have actually managed to do is I've managed to form just because I'm active member of ESO, but I'm also an active member of another society, which I'll briefly tell you about, which is called FENS, the Federation of European Neuroscience Societies. And through being active in both of them, actually managed to form a memorandum of understanding between the two societies to get the scientists and the clinicians genuinely talking. And it's that, they're small things, but hopefully it might actually help down the line. And then very briefly, in a leadership capacity, I am the past president of Neuroscience Ireland. And in that capacity, obviously, it was important from an Ireland perspective, but the president represents the national society in this Federation of European Neuroscience Societies, which I just mentioned. So it gave me the opportunity to be involved in the governing council and also to become involved in some of the core committees within FENS, such as the Committee of Higher Education and Training. And through doing this, I think I was actually able to have a direct impact on some policy things, which is the most closest to actually being able to give you some tangible evidence that, I had any influence at all, to be honest, through this. So just in terms of what FENS is, the reason why it is so powerful is because it's very large. It represents 22,000 scientists in many, many countries, and it is obviously very interested in advocating for all things brain research. But just two examples of things that I was actually able to be involved in doing is, for example, there was great alarm in Europe in May 2022 when suddenly brain health was cut from a programme of research. And there was then this attempt to have a coordinated response to try to reverse this. And through FENS, all of the national entities were requested to contact their national entities, which of course I was able to do. And we actually did get it reintroduced, right, within quite a short period of time. And then another thing that happened was obviously Brexit happened and Britain got kicked out of Horizon Europe, and there was great alarm within the scientific community here. And again, through FENS, there was en masse mobilisation. There was a joint letter to the European Commission, and within about a year, then Europe were allowed to rejoin Horizon Europe, granted as an associate member, but it's that kind of thing. So I don't know if that helps at all. I am genuinely just a tiny cog in a very big wheel, but that's just my experience and how kinds of things I've been involved in to date. Okay, thank you.
Thank you very much, Karen.